Hello students, I hope you all are doing well. I am Prithviraj, your Raj sir. Today I have brought a new topic which is redox reactions. The chapter is very important for J mains, J advanced, Neet and all formats. So my dear students, we are constantly reading chapter called stoichiometry. So this redox reaction chapter is somewhat you can say it is second part or stoichiometry part 2 you can say, or mole concept part 2 also you can call. Okay, so in this particular series of topic what all things we'll understand, this particular chapter will come in several videos my dear children, and this is our first part. So in this topic we will be discussing how to identify both reduction and oxidation in a reaction, and what is redox reaction, how to balance redox reaction by number of methods, and we'll understand how to calculate n factor. Then I'll teach you equivalent concept, which is many students may face difficulty about these topics. I'll teach you how to attempt the question, how to understand the topics. I'll give you several examples. Okay, and before we start this topic we have to learn what is oxidation number and what is oxidation state, how these things are working. Okay, so today the entire topic is about oxidation number. तो चलो शुरू करते हैं बच्चों. What is oxidation number? If someone will ask you, generally if somebody is asking you what is oxidation number, what should be your answer? What else you can do? क्या होना चाहिए? I hope you can see here NaCl. NaCl, if you'll dissociate it, you will get Na plus and Cl minus. So बच्चों plus 1 is the oxidation state of sodium, whereas Cl minus is the minus 1. Cl is possessing minus 1 oxidation state. If you talk about Al3 plus, and here chlorine is also getting minus 1. What about CO2? CO2 is covalent. Here charge is present, isn't it? Charge is present, and it is called virtual charge, not real charge. How we'll get to know? See, CO2, sir, we have learned from our childhood lessons that basically CO2 is a covalent compound. Here electrons are not being shed, electrons are not being transferred, then how they will have charge? Children, here the game is all about what you call electronegativity. Okay, the one who's more electronegative, that particular component will be achieving negative charge. The one with less electronegativity will be achieving what? Positive charge. Okay, so in CO2, and these charges are basically virtual charges, not real charges. But when we talk about ionic compounds, these charges are called original charges. Again, in ionic compound, charges are called original charges, whereas in covalent compound, the charges attained are called virtual charges. In any compound, the charge present on the element is called oxidation number. In any compound, suppose we will take an example of H2O. In this compound, whatever charge hydrogen and oxygens are possessing are basically called as oxidation number. Further, for ionic compound, charge is real, whereas for covalent compound it is virtual. You can see the example of carbon dioxide. Here carbon is containing plus 4 charge, oxygen is having minus 2, oxygen having minus 2, because double bond is there. It is game of electronegativity. As I said, A is having negative charge, B is having positive charge, isn't it? The one who's more electronegative, A, will have negative charge. The one who's less electronegative, B, will have positive charge. Okay, you see here, if A and B are having double bond, then you see they both are having what you call dual charges, like minus 2 plus 2. So for each bond, single plus or negative charge will be given for each bond. If A and B are forming the compound, then for each bond you will be giving either plus charge or you will be giving minus charge. It depends upon the compound which you are talking about, isn't it? Next, but so how to calculate oxidation number? Very easy. There are few rules which you have to remember, then everything will be very smooth. If you see here, the oxidation number of an element in its standard state is called always 0. What is standard state? Elemental state or natural state is called standard state. Hydrogen is always a gas. If hydrogen is a gas, and if you're normally finding hydrogen gas, definitely its oxidation number is 0. O2 is also 0. O3 is also 0. Some of you may ask, sir, O3 is have minus charge, this and that. No. O3 in ozone layer, when it is existing comfortably, even it is existing in the format of gas only. So even it is having oxidation number 0. If you talk about Cl2, if it is a gas, its oxidation number is 0. Bromine, if it is a liquid, its oxidation number is 0. If iodine is solid, then its oxidation number is 0. In addition to that, P4 and S8, even these people's oxidation number will be 0, because that is what their natural state is. Okay, this first point. Second point, all alkali metals are basically group 1. Okay, group 1 metals, all group 1 metals are having oxidation number of +1. Here we didn't add francium because francium is radioactive or it is very rare. So I believe that is the reason we didn't add. If you talk about second group, which is group 2 in the periodic table, okay, group 2 in the periodic table, these people are called alkali earth metals. And here barium, magnesium, calcium, strontium, barium, all of them will have +2 oxidation state. Always, okay. Now unique compound is hydrogen. Always remember hydrogen's oxidation state is +1 when it is attached with more electronegative element. Basically all non-metals are more electronegative to that of hydrogen. Okay. So children, in HCl, H will have plus charge, Cl will have minus charge. In water, H will have plus charge, whereas oxygen will have minus charge. In ammonia, nitrogen will have minus charge, whereas hydrogen will have plus charge. But if hydrogen connects with a less electronegative element, then its oxidation number will be minus. Who are less electronegative? Basically, metals are less electronegative. You see here sodium hydride and magnesium hydride. Here magnesium is attaining +2, hydrogen is attaining -1. Each hydrogen is attaining -1. Okay. So this is one more part. Most important part is oxygen. Oxygen have few cases also. I'll teach you everything line by line. Oxidation number of oxygen is always -2 when attached to less electronegative compound. Okay, if oxygen is attached to less electronegative compound, then it will always show you -2 generally. But there are few things which we are observing. What it is? First is peroxide linkage. When oxygens are making peroxides, at that time oxidation number is -1. As you can see, O bond O, such type of linkage is called peroxide linkage, or this is called peroxides. You see here hydrogen and hydrogen, two oxygens. This is basically H2O2, and this is called as H2O2. And here you see, my dear children, oxygen and oxygen having one peroxy linkage. That's the reason it is attaining -1 and it is also attaining -1. Okay. I hope you have understood. Next is your super, and this structure is called open book structure. Okay, this structure is called open book structure. And kindly comment me what is its common name. Okay, common name for H2O2, you comment. Okay, I hope you will comment. Next, what are superoxides? Superoxides are having charge like this, O2 single minus. In chemical bonding, you have learned, I believe, molecular orbital theory. In molecular orbital theory, you might have understood how O2 minus is being formed. If not, if time permits, even I'll make what you call videos upon all the topics of chemical bonding. Okay. Now, children, oxidation number of oxygen is -1/2 here. Okay. For example, KO2, potassium superoxide. You see, potassium has +1 charge. Here, each oxygen having -1/2 and -1/2. That's the reason total oxidation number is 0 of the compound. Again, same thing, NaO2. This is sodium superoxide. Here also the same thing is happening. Sodium is having +1, each oxygen are having -1/2 and -1/2. Collectively, they will be calling +1. Third one, most important topic, oxyfluorides. Oxygen is second most electronegative element in the periodic table with electronegativity around 3.5. Fluorine is first, which is having electronegativity 4. So when fluorine is being attached with oxygen, what will happen? Oxygen will attain +2 charge and fluorine will attain -1 each. This one another structure which is F2O2. This is also one more open book structure. Here you see one peroxide linkage is present. So each oxygen will have -1. No, here in presence of fluorine, each oxygen will attain +1 charge. Okay, it's the only case where oxygen will show you positive charge, my dear, or else everywhere, okay, oxygen will have negative oxidation state. The next point, the oxidation number of halogen is generally -1, isn't it? Generally it is -1. Who all halogens? Who all are halogens? I believe all of you know, that is fluorine, chlorine, bromine, iodine, and astatine. We will never consider astatine because astatine is radioactive. Okay. Now their general oxidation state is -1 if it is attached with less electronegative element. Okay, if you see here HX, H will always have plus, whereas X will always have -1. When a halogen is attached with more electronegative element, then even it will have positive oxidation state. Okay, even halogens can have positive oxidation state if they are attached with more electronegative elements. For example, here you can see OCl2. In example of OCl2, Cl both are attaining +1 charge. In ClF3 also, Cl will have plus charge. You can see here, this is your fluorine, which is more electronegative, so it will have -1, -1, -1. Children, you need to remember fluorine's electronegativity is around 4, chlorine's electronegativity is around 3, nitrogen's electronegativity is around 3, Oxygen's electronegativity is around 3.5. Hydrogen's electronegativity is around 2.1. It's enough. Okay, these things are gonna be useful always. Okay, these things are going to be useful everywhere. So kindly remember. And listen, when compounds are being formed between two hydrogens, these are called interhalogen compounds. These are called what? Interhalogen compounds. You can see here IF7. In the case of IF7, you see I is connected with 7 fluorines. You might can ask, sir, why I? Why not chlorine? But a chlorine का size बहुत बड़ा है. Chlorine is bigger. So bigger size, I believe it cannot accommodate 7 chlorines in one iodine atom. Okay, it will create steric hindrance. It will create what? Steric hindrance. Steric hindrance का मतलब मैं पहले ही बताया था, आज भी बता रहा हूँ, इसका नाम है जगह नहीं है. Place is not enough. Okay. Children, the most electronegative element is fluorine. So it is always -1. Fluorine हमेशा -1 ही होता है. Okay, fluorine is always -1. Okay. In Hindi we say one statement, हर किसी का बाप होता है. Even fluorine has positive oxygen state in this particular compound, which is HOF. It's an acid. Comment in comment section what is its common name. Okay. Common name आप लोग कमेंट करो. अगर आप वीडियो अच्छे से देख रहे हो तो कमेंट करना. Here fluorine is always showing +1 oxidation state, and it is the only case which I found. Maybe this statement is contradictory. Many statements they have given many things, but what I have done my research, fluorine is +1 in this particular case. Okay, we don't have to get into details. This is what you have to remember. Now, most of us do not cover this point. Here the point is radicals are considered as single unit. Radicals are considered as a single unit, and the charge present on them is taken as their oxidation number. There are few radicals which I have written which will be very useful for your students. I'll pause, you can take the screenshot. Okay, I hope you have taken the screenshot, or I hope you have written it. You can pause and you can write all these things. Name of the radical, charge, and everything I have written. One is X minus, one is O2 minus, one is N3 minus, P3 minus, S2 minus. You see, these are called halides, oxides, nitrides, phosphides, and sulfides. Okay, these all are monoatomic radicals. If you see compound type radicals, OH minus, hydroxides, Cn minus, cyanide, NC, isocyanide, SO3 2 minus, sulfide. Children, in SO3 2 minus, S is having +4 oxidation state. This is called sulfide. In SO4 2 minus, S is having +6 oxidation state. Okay, this is their oxidation state, the charge which is kept upon them. Here these things I have solved it for you guys. Sulfur's oxidation state in SO4 2 minus, if somebody will ask, you will say, sir, it is +6. Okay, compound you can make is H2SO4. Then here PO3 2 minus. Children, PO3 2 minus is basically called phosphite. Charge is -3. Here oxidation state of P is +3. Okay, one more is phosphate. Even in phosphate case, you see -3 is the charge, but here the oxidation state of P is +5. Okay, phosphate, phosphite, sulfate, sulfite. This difference and the numbers, kindly focus. Everywhere it will be helpful. Okay, next, NO2 single minus is called nitrite. It is having -1 charge. NO3 single minus is called nitrate. It is having -1 charge. Here nitrogen is +3. Here nitrogen is +5 oxidation state. Children, wherever you are seeing bigger oxidation state, they will use nitrate. Smaller oxidation state, nitrite. Here also you see bigger oxidation state, phosphate. Smaller oxidation state, phosphite. Here also sulfate, sulfite. Okay. Next, these are three very important, very rare, but very often you will find in second year or first year in various aspects. Okay, kindly see C2O4 2 minus. Children, this is called oxalate. This is called what? Oxalate. Okay, it is having charge of -2. S2O3 2 minus. This is called thiosulfate. Okay, and S4O6 2 minus. This is called tetrathionate -2. One more, children, MnO4 2 minus. Okay, this is called manganate ion -2. And here you see MnO4 single minus. This is called permanganate ion, which is having -1 oxidation state. Here magnesium's oxidation state is +7. Here magnesium's oxidation state is +4. Then we talk about chromate 2 minus, CrO4. Then dichromate CrO7 2 minus, which is -2. याद रखना, CrO7 2 minus usually stays in orange color. Okay, if it is potassium, this stays in almost always, I think this stays in yellow color. Okay, most of the time. And children, SCN minus, this is called thiocyanate. NCS, this is called isothiocyanate. These are also having -1 oxidation state. One more thing I have mentioned over here, radicals, very important radicals. ClO minus, these are basically hypochlorite. ClO2 single minus, this is called chlorite. ClO3 single minus is called chlorate. ClO4 single minus is called perchlorate. If you will focus nicely, my dear kids, you see chlorine is having +1, +3, +5, +7 oxidation states, right? All of these oxidation states are coming. When highest oxidation state came, perchlorate you have written. When mediocre order or highest order came, chlorate you wrote. Little bit weaker you wrote chlorite. Very weak, I mean very small oxidation state, you wrote hypo. Okay, very small oxidation state you will use hypo. Common you will use chlorite. Bigger you will use chlorate. Very big you will use perchlorate. Per वाला word आएगा, ATE and per. Here one more thing I forgot to tell you. Here only I'll explain. Okay, in halogens they will show you different type of oxidation state like +1, +2, +3, +4, +5, है ना, +6, +7. All these formats of oxidation state they can show you. Generally they will show you +1, +3, +5 and +7. This set of oxidation state you will always find. Okay, I have written all of them. These are in I mean if one hydrogen has gone, something has gone, they will show you, but always they will show you +1, +3, +5, +7, except fluorine. Fluorine can only show you -1 and +1, nothing else, because of absence of d orbital. Absence of d orbital. In all other cases, you will find vacant d orbital. One example I'll give, that is of chlorine. Chlorine's atomic number is 17. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. If 3 came, that means this is third orbit from nucleus, 1, 2, third orbit. Third orbit, if n is equal to 3, L will be 2, so you will have D, P and S all orbitals. S orbital is filled, which is 3s. One more is suppose 3p, 3, and one more is basically 3d, 1, 2, 3, 4 and 5. So children, 3s2 is filled, 3p is what filled again, 1, 2, 3, 4 and 5. Vacant d orbital is present. If excitation happens, what will happen? Now this will remain as it is, 3p will be vacant. Okay, and those electrons will get into d orbital. Here 1, 1, 1, 1, 2. So you see now what is the case? Before it is +1, before it is +1, अभी क्या हो गया, +5 तक हो सकता है. Okay, one more, if you remove this electron also, it will come all the way up to here. Now you see +7 is also possible. So that's the reason I am saying, because of presence of vacant d orbital, halogens can show you +1, +3, +5 and +7 oxidation state sometimes, and it can be only shown when they are reacting with highly electronegative compounds like them fluorine and oxygen. Okay, याद रखना, बहुत इंपॉर्टेंट क्वेश्चन है. स्पेशल केस ऑफ ऑक्सीडेशन स्टेट ये भी हम पढ़ेंगे बच्चों. इससे पहले, बिफोर दैट, वन थिंग यू हैव टू रिमेंबर, द सम ऑफ ऑक्सीडेशन नंबर ऑफ ऑल द एलिमेंट्स प्रेजेंट इन ए मॉलिक्यूल is equal to net charge present on it. Okay, if you talk about SO42 minus, oxidation number of S is how much? We'll find out. Okay, and oxidation number of oxygen is -2. This is always, we always remember that oxidation number of oxygen is -2, and S we have to find out. So let us take S as X, and we have multiplied 4 with -2, we got -2. I mean overall charge, isn't it, -2. So X is equal to +6. Here we should apply the rule which we have learned previously. What all rules we have understood, like oxygen and all rules I have taught you, 5 rules that you will apply. Okay, now MnO for single minus, overall charge is -1, that means X plus 4 into -2, then X came +7. We'll calculate all of their oxidation states now. Okay, this will cover half of your stuff. Let's see. CrO7 2 minus, 2x plus 7 into -2 is -2x, है ना. H2O3 2 minus, 2x plus 3 into -2, -2, x is equal to +2. So children, I believe all these oxidation states you can see clearly. आप लोग थोड़ा शांत हो जाओ. You stay pause for stay put little bit. Check the answers I have written for everything. Okay, and little things I want to explain you. Here what I need to explain is, here NiCO whole 5. Here CO is carbonyl group. Carbonyl group's oxidation state is always 0. Okay, that is the reason nickel is having zero oxidation state. If you talk about NH4NO3, ammonium nitrate or ammonium nitrate, here what happens, you have to break independently, you have to calculate. Here N is having -3, here is N is having +5. तो इसको बहुत अच्छे से आप लोग देखना. And these square brackets are depicting coordination compounds. Here X is 6 into -1 is -3, which is X is equal to +3, isn't it? And here X is equal to +1. And here you see, children, this is unique case where Fe3O4 you found out X is equal to 8 by 3. What you found, X is equal to 8 by 3. This 8 by 3 type of oxidation state is called average oxidation state, about which we are going to discuss. Very special or exceptional cases, children, CrO5, here you see oxidation state is 10. You need to understand it's never possible, because maximum oxidation state is always 8, which is osmium wala compound. You can see here OSO4. Okay, and here you see osmium oxide, whatever you are seeing, tetraoxide, osmium tetraoxide. Here osmium oxidation state is +8. This is the maximum oxidation state which you can ever see. Okay, structures can say. Then who will answer? Structure will answer. Children, here two peroxy linkages are present. Cr double bond O. Okay, this is the case. Here everywhere 1, 2, 3, 4, 5 and 6 bonds are formed. So Cr will have +6 and rest everything I hope you can see. This is deep blue in color and we call it blue butterfly. Okay. Next is Carros acid. Remember the name, remember the formula, H2SO5, Carros acid. Here you see S double bond to double bond. Whenever S type of oxides you are seeing, children, give directly double bond to sulfur anyhow. So two double bonds you have given, one single bonds you have given, one more oxygen where you will keep with peroxy linkage only, here no place. Okay, then hydrogens at the end of the day. You see everybody's atomic number is clearly mentioned. Here sulfur's oxidation state is +6. Okay. Next is Marshall's acid. Marshall's acid is the combination of two sulfuric acids followed by removal of H2. Okay, here you will get what? H4S2O8, but remove two hydrogens, then you will get Marshall's acid. As you can see, remove both, you will be getting this is what Marshall's acid. This peroxy linkage. Okay, बीच में एक peroxy linkage है. Both sulfurs are having plus oxidation state. If you talk about Fe3O4, children, what you got? +8 by 3. This is average oxidation state. You might see the formula for average oxidation state, which is total charge on the element in the compound divided by number of atoms. Okay, here 3 irons are there, so we have taken 3x plus 4 into -2 is equal to 0, because overall charge of the compound is always 0, neutral compound ka hai na. Radicals means charge whatever it is given. So what is the real oxidation state here? Children, Fe3O4 is a mixed oxide. Okay, it has two oxides, one is FeO, one other is Fe2O3. So average oxidation state will be 1 into +2 plus 2 into +3 whole divided by 3, which is 8 by 3. But independently, if you will see, FeO iron is having +2, here Fe2O3 iron is having +3 oxidation state. That's why here you will write the answer as +2 and +3. Next, tetrathionate. Tetrathionate is basically S4O62-, which means you can talk about H2 also. This compound is basically H2S4O6 type compound. Here also you see average oxidation state is same formula what I told you, 4x plus 6 into -2 and x is equal to 10 by 4. It is average oxidation state. Reality is this. You see 1, 2, 3, 4 sulfurs, and end of the sulfurs have got double bond and these got single bonds. If you'll check, children, if you'll check it properly, here this sulfur is having +5, this sulfur is having +5, and these two are having no oxidation state because similar type of sulfur they have attached to. And if you will attach hydrogen at the end of each, you see every other oxygen is getting -2 oxidation state. So your answer should be 5 and 0. Okay. And bleaching powder, one more important concept. Bleaching powder structure is this, children. Ca, one is attached with chlorine, another is attached with O and Cl. So one chlorine is +1, another chlorine is -1. Average is coming 0, but here it is not 0, my dears. Okay, you see here one chlorine is +1, another chlorine is -1. Your answer should be +1 and -1. That's why net charge is coming 0. But in reality, both chlorines are having different oxidation states. One is +1, other one is -1. Barium thiocyanate. This is one new compound which is introduced for you. I believe, you never have heard about it. This is barium. Okay, attached with two SCN compounds, thiocyanate compounds, SCN, C triple bond N. C will have +4, obviously 3 from nitrogen, 1 from sulfur, like both of them are taking, and sulfur is taking from barium also. So barium will attain +2 oxidation state and these guys, sulfurs will have -2, carbon will have +4, and nitrogens will have -3. So all oxygen states are independently written over here: sulfur -2, carbon +4, nitrogen -3. The most important part is contribution of coordinate bond. What it is? Contribution of coordinate bond. So contribution of coordinate bond part I will teach you, children. I don't know whether you can see or not. I am unable to expand this. Yeah, I can expand right now. So here we will be talking about this contribution of coordination compound in two parts. One part, if the coordinate bond points towards a less electronegative atom to more electronegative atom. One more case we will read, if it is pointed towards more electronegative atom to less electronegative atom. So first of all, you have to understand what is coordinate bond. What is coordinate bond? If somebody will ask you, see children, we'll talk about ammonium ion. Okay, ammonium, NH3. When ammonium is happening, one H plus ion will come. H plus doesn't have any electron. Nitrogen have two electrons. So what will happen? Nitrogen will give one of its own electron to hydrogen. Okay, then it will make bond. So in such case, we will call it coordinate bond. We'll call it what? Coordinate bond. This is called coordinate covalent bond. Coordinate covalent bond. So there what they are saying, if less electronegative element towards more electronegative element, if coordinate bond is shown, okay, if coordinate bond is shown, then similar to our rule, which is +2 and -2, because it is more electronegative, give it, no issue. If it is happening other way around, see here coordinate direction is O to C. These bonds are directional bonds. Here more electronegative element to less electronegative element, this direction is given. In such case, you don't have to consider any oxidation state. And children, this coordinate bond theory will be useful in class 12th. Okay, so remember this concept. Whenever you are having doubt, you can always come back to me. And at the end of the day, what is the main difference between or comparison between valency and oxidation number? Children, valency is combining capacity of an element, whereas charge present on an element in a given molecule is called oxidation number. Okay, valency can never be fractional or negative. Okay, it is always an integer value. 0 in case of noble gas, but oxidation number can be fractional, it can be negative, it can be 0 also. Okay, and if it is an ionic compound, in that case valencies and oxidation number, generally both of them are very much same, my dear. These two are very much same. Okay, this is the end of our topic, which is called coordination number. And for you, I have one more question, which is Br3O8. Can you find out the oxidation number of Br? I'll give you the structure as well. Br, Br, and Br everywhere. Okay, children, double bond O, 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 double bond O. I believe you got Br3O8. Here, please tell me what is the oxidation state of Br. Comment in the comment section if you have understood the entire topic, and tell me if any doubts are there. Whatever it is, kindly let me know, and suggest your friends to watch this video so that even they'll get benefit out of it. So after this is it, children. I'll meet you soon. I hope you all know this is your Prithvi sir. Okay, bye, take care.